So now, having established that momentum is always conserved and that there's no getting around it, let's write out a nice little formula we can use mathematically. So what we're going to do is we're going to say that we're going to have for instance, let's think of this two-body system above. So just to make it clear, this momentum being conserved means that momentum before interaction is just momentum after. We're just going to write momentum before has to be the same as momentum after. So how do we apply that to our situation above? Well, we've got these two balls hitting each other. Excuse me. Just had some interesting graphical issues there. So starting to use this situation to mathematically talk about what we got going on up here, we can write this slightly better, since momentum before, momentum after really means sum. I'm going to use this little sigma symbol to mean sum. So you sum up all the momentums of all the particles you had before, and then that has to be the same as the sum of all the momentum afterwards. So if this here, we're going to call this particle A, this particle B, which means that this has MA, this has MB, and this is going to have UA, U meaning initial velocity, A meaning particle A, and this is going to have UB, same as before. And then down here, we're going to have this VA, meaning velocity afterwards, and VB, meaning for velocity A, meaning velocity for this one afterwards, and VB, meaning velocity for particle B afterwards. We're not going to worry about directions. We're actually going to say that all the directions are in this way, just purely because signs are really important. Remember, again and again, as I've said, momentum is a vector quantity, but we're just going to use this here as an example. We're going to have all of our velocities going in the same direction because it'll make this a heck of a lot easier. So mathematically, what's going on? What's our momentum before? Well, it's MAUA is the momentum of this particle here. Excuse me. And MBUB will be the momentum of this particle. And, well, what's that going to be afterwards? Well, it's exactly the same. We just put VA instead of instead of UA, etc. So that's going to give us MAVA plus MBVB. And there we go. That's the equation we use. So just to really whiz us through a quick example of how this works, we're basically going to just find what the velocity of...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.